Hi, my name's Gabe. For this problem, we're given the function f of x is equal to 3x squared divided by x squared minus 1, and we're asked to find the domain of this function and then describe the behavior of the function near any of the excluded x values. So in order to find the domain of this function, all that we're looking for is the values which make the denominator equal to 0. So to find these values, let's go ahead and let's set the denominator equal to 0. So we'll set x squared minus 1 equal to 0. And here, we can solve this a couple different ways. We could add 1 to both sides, take square roots, or we can factor. Let's go ahead and factor. So this factors into x plus 1 times x minus 1. And this is equal to 0. We can use the zero factor property. And we end up with x plus 1 equals 0, or x minus 1 equals 0. Subtracting 1 here and adding 1 here leaves us with the two values that we're going to exclude from our domain, x equals negative 1 and x equals 1. So the domain is going to be all real numbers except for x equals negative 1 and x equals 1. Now for the second part of this problem, we're asked to describe how the function behaves near these excluded x values, so near x equals negative 1 and x equals 1. And how we're going to do this is just by looking at two tables. So the top one, we're going to look at the values as these x values approach negative 1. And this bottom table, we're going to look at what happens to the function as the x values approach 1. So how we're going to do this is we're going to choose a couple values to the left and to the right of both negative 1 and 1. So in this top table, we want to think about, well, what happens as x approaches negative 1 from the left, and what happens as x approaches negative 1 from the right. And down here, we're going to want to think about, well, what happens as x approaches 1 from the left, and what happens as x approaches 1 from the right. So what we'll want to do is let's just start by thinking about approaching negative 1 from the left. So here we'll want to choose values just a little bit smaller than negative 1. So let's start with negative 1.01. And coming a little further, let's choose negative 1.1. So now we can go ahead and we can evaluate each of these using a calculator. So if I evaluate our function when x is negative 1.1, we see that the function value is approximately 17.29. Now this piece of information right here doesn't tell us a whole lot, so we'll have to see what happens when we evaluate our function at negative 1.01. So evaluating our function at negative 1.01, we see that our function value is approximately 152.25. Now, if you wanted to take this a couple steps further, you could evaluate your function at negative 1.001. And what you'll see is that these numbers, the function values, keep increasing without bound as these x values get closer and closer to negative 1 from the left. So what we would say here is that as these x values approach negative 1 from the left, our function approaches infinity. So it increases without bound. Now we're going to have to do the same thing as these x values approach negative 1 from the right. So here, we're going to want to think about some numbers, let's say negative 0.99 and negative 0.9. So let's start by evaluating our function at negative 0.9. Now, the function value here is approximately negative 12.79. And if we evaluate our function at negative 0.99, the function value is approximately negative 147.8. So what we're seeing with these values is that as x starts to approach negative 1 from the right, well, these values keep getting smaller and smaller. And you can verify this by finding the function value at negative 0.999, let's say. So what this means is that as x approaches negative 1 from the right, our function decreases without bound. So what we'll say is that as x approaches negative 1, our function value approaches negative infinity. So now we're going to do the same thing, except this time we're going to be looking at what happens as these x values approach 1. So looking at approaching 1 from the left, we'll want to think about numbers that are just a little bit smaller than 1. So let's say 0.99, and let's say 0.9. So now we'll want to evaluate our function at 0.9 and 0.99. Let's go ahead and do 0.9 first. So we see that at 0.9, our function value is approximately negative 12.79. And evaluating our function at 0.99, our function value is approximately negative 147.8. So what we see here is that as these x values get closer and closer to 1 from the left, so as x approaches 1 from the left, it appears that our function values keep decreasing without bound. So what we'll say is that as x approaches 1 from the left, our function value approaches negative infinity. Now finally, we'll have to do the same thing over here, except now we're going to be approaching from the right. So we'll want to think about values that are just a little bit bigger than 1. Let's say 1.01 and 1.1. So let's start by evaluating our function at 1.1. So evaluating our function at 1.1, we see this value is approximately 17.29. And we'll evaluate our function at 1.01. And in doing so, we see that our function value is approximately 152.25. So what we see here is that as x approaches 1 from the right, our function values keep increasing without bound. So what that tells us is that as x approaches 1 from the right, our function value approaches infinity. So just to recap, what we have is that as x approaches negative 1 from the left, our function value approaches infinity or increases without bound. As x approaches negative 1 from the right, our function value decreases without bound or approaches negative infinity. As as x approaches 1 from the left, our function value decreases without bound or approaches negative infinity. And as our x values approach 1 from the right, our function increases without bound, so we say it approaches infinity. Thank you.